Can't hear you, sir. Oh, you're not talking.
I didn't know that I muted though. That's why I don't like muting. So that should have all the talking. Okay. Let me go back. It was because when we started something, I didn't want to be, somebody was talking to me here. I didn't want to, be talking so that you're hearing. That was why I muted. And when I started, I didn't even mute. That should all the talk go. So let's start now. I think some people have joined, at least not just joined. So that is the name person that joined. Making 4 of you. So I said that validity and reliability. We want to talk about validity and reliability. This validity and reliability, they are very, very important for a researcher. Before you conduct your research, before you carry out your data collection on the large scale, you need to determine the validity and reliability of your instrument. Your tool, when I say instrument now, your tool, your questionnaire, your proforma. It's not only that one. Even there are some other instruments you use to capture, like for example, weighing scale. All those things need to get that they are valid, they are reliable. Can you see that? Also, when we talk about validity, we talk in context of measuring one variable, even how to measure all the variables, the whole of this method. When we say a method, a weighing scale, whether you are using bedroom weighing scale or another weighing scale, or maybe digital or analog, that method of weighing, you need to get the validity of that weighing scale you are using and the reliability of that same instrument. But that just on a lighter note of that was just targeting one of the variables. But the whole method, your study design, you need to calculate determine the validity and reliability. And what are you? The whole method and the major thing is the instrument we are using. Yeah, I mean, when you say instrument, your questionnaire, the whole questionnaire that capture everything. For example, now I want to know, you want to determine level of depression, if there's any depression. The question is composite. You cannot just ask, it's about question. It's not as if maybe they measure or something, they say you are depressed. It's not like blood pressure. It's something they ask you some question. And at the end of the day, that's they calculate, have a cutoff point, they look at the screen and say, you have bipolar depression. So those are the things that in psychiatry they do. So as far as they are concerned, that particular question is an instrument. It's the same thing. You want to measure the perception. That set of questions for that person is an instrument. So you need to validate them. You need to determine the reliability. So once an instrument has been developed, the reliability and validity of the instrument need to be evaluated. Reliability and validity are two ways that researchers evaluate the quality of an instrument. Validity means the success of a method in probing or assessing what is said to probe or assess. That is, if you want to measure my weight now, and my weight is 70, and maybe that weighing scale consistently remove 5, is usually short by 5. Maybe the weight was set. So if I stand there, to give me 65. If somebody is 85, you give 80. If somebody is 90, you give 85. So consistently is removing. So that shows that it's not valid. It's not actually measured. So whenever you measure your weight, it's not your weight it has measured. So in that is valid, it's not valid. That's just for a piece of instrument that's just capturing one variable. But the whole question here also, for example, you want to measure the pressure, and I say, the proportion of people that are depressed is 20%. And whereas the people that are there, maybe they are 30%. So in as much that he didn't get it, it's not valid. Because somehow the instrument has not captured the pressure, the proportion that are depressed. I don't know if you understand me now. So validity now means that this method or instrument you are using, the ability of it to measure what it's supposed to measure, that's validity. If the method is valid, then the difference in the result between individual group can be taken as representing true difference. For example, now, the weighing scale that is removing 5-5. If you are comparing weight of two group of people, urban and rural people, you want to know the average weight, comparing their weight. In as much as that weight scale you are using, all those weight scale you are using, they are not valid, they are not actually measuring the weight very well. So whatever difference you say you find is not valid. It will not be correct. So reliability refers to consistency of data stemming from the use of particular research or tool. So, we talk about this weight scale now that you measure that is just measuring 5 less, it's not valid. You may see if you yourself, it mean that you say I'm 65. If I come out and do it again, it give me the same 65. I come and give me, so it may be reliable, it's consistent, but it's not just valid. But sometimes it may not be consistent. I can stand, give me 75, later give me 68. You know, I stand again, give me something else. That's so that the weighing scale is not consistent. And why are you going to see the relationship between reliability and validity? So if it's not consistent, there's no way you can measure what it's supposed to measure. So if a method is not reliable, it cannot be valid. But it can be reliable without being valid. It can be reliable without being valid. For example now, it is reliable, but it's not valid. But if it's not reliable, it cannot be valid. So now, there is no way something you can say, you say method is valid, but it's not. No. Reliability first. If it's not measuring the same thing all the time, how can it measure the actual thing? But it can be measuring the same thing all the time, but it's not actually measuring the actual thing. It can be consistently wrong. It can be consistent, yes, it's not measuring the right thing. A test can be reliable but not valid, but a test cannot be valid without being very reliable. In other words, reliability is a necessity but not sufficient condition for validity. It is a necessity. Something can be reliable, yes, that's right. It must be reliable first. But reliability does not, it's not only reliability that makes it valid, but reliability is a necessity for validity. But that's not the only factor that makes instrument valid. So it's just the first step. We know that if it's not reliable, it cannot be valid. It can be reliable without being valid. So let's look at this dart. Let's see. Interaction of variety and reliability. Imagine this purple area, and this dart is what you are targeting. You are throwing arrow, other than shooting dart. Look at it. You are targeting the purple area. Look at the first one. It's just scatter. Somebody is supposed to target the purple. It's not targeting the purple. It's not valid. Even where it's targeting outside, it's not consistent. It's not reliable. So that first one that is just scatter, arrow scatter. The person shot the arrow system. They are just look at the way they are scatter. The person is neither reliable or valid because it's not even for one even touch the purple area there. And it's aiming at the purple area. Look at this second one. He's aiming at the purple, he's aiming outside. So the person is consistent, is reliable, but it's not valid because he's not targeting the purple area. Look at this one now. This one is all the time consistently is hitting the purple area, is both reliable and valid. If the same thing, the one below is the same thing. Look at this other one scatter, neither reliable nor valid. This one reliable nor valid, but this one both valid and reliable. Of course, for it to be even valid, it's first not reliable. So it's the same thing. You see, though some people say not valid, not reliable, valid. No, not reliable, valid. No, there's nothing like that. Yeah, it cannot be. It may not be valid. It may be valid. It may not be reliable. It may be reliable and valid, and reliable not valid. So there are some things about it, though this one you may not even need, but there are some definition of task about some tests, some method, practicality, economy of time, effort, and money in testing. If something is practicable. If something is too costly, or it takes some time, it may take some time. It's not something you can achieve within short time. And in the morning also, it's too costly. It's not practicable. You may say, this one is a good test, but it's not practicable. It's just like they say you want to do something, do one test now, and all your salary for the whole 5 years cannot even do it. So you forget about it. It's not practicable. So there are some other things. A test should be easy to design, easy to administer, easy to interpret. It's called something backwash effect, influence of testing on teaching and learning. So if a test cannot be taught and cannot teach people, cannot improve people's learning, it doesn't have that backwash effect. So let's look at there are different aspects of reliability, different type or perspective. Look at that's what I just showed here. Type of inter-rater. In this inter-rater, what it means is that inter-rater. So there are some things you are capturing data, you are rating. For example, now the doctors, okay, it's only Ngozi here. Okay, you want to rate something. Maybe you just look, you rate. The dentist, they do it a lot. In medicine, usually you finger clubbing, you want to finger clubbing to rate finger clubbing. So it depends on your, though they will have told you, you will have learned. If it's like this A. If it's like this, grade 2. If it's like this, grade 3. So people are taught to do it. But for the fact that people are taught to do it doesn't mean that people have the same expertise. All people have the same expertise. All the people that are taught have the same expertise. So when you are rating, you want to know if this method is reliable. Inter-rater means I rate, another person rate. If you are another person, if maybe you have many data collector, you have this person to rate, different people rate, you have trained them. Are they, even though with the training, if they pick one person, you ask one person to rate, there's another person rate that person. Are they rating the same thing? That's inter-rater reliability. Even you, one person that rates, you may come back to rate again. Will you rate the same thing? That is intra-rater. Intra, in between rater. So sometimes you look at percentage agreement. You rate another person, you want to say, what percentage are they, to what extent do they agree? They are part of measure of reliability. That one is under scoring agreement. In reliability, when you know that somewhere you use scoring agreement. Now, inter-rater, most of the time, it doesn't have quantitative. It's just you rate there, not there, or grade A, grade B, grade C. But the other one is maybe you put value. So that's why you talk percentage agreement. You can only do the percentage agreement with that one that has quantitative value. The one you just categorize grade A, grade B, grade 1, or grade 2, grade 3. And all those grades, that's rating. So they are all scoring agreement. We have what's called test reliability. In this way, you do a test, you administer that test, that instrument. So you now ask them to go by, your people to go by. The same people they administer the test to do, and maybe after 1 or 2 weeks, it has to be long enough for them to have forgotten what they told you before, what they choose before. It has to be short enough for the attribute you are measuring has not changed within this person. Can you see now? When I did it I used that test for my part 2. It's about quality of life. We administered the quality of life, and they took their name, those same people, without waiting for 2 weeks, believing that within 2 weeks their quality of life has not changed. But they will have forgotten what they choose for each question. You administer the question to them. We want to see how close are the what the P. So that is test retest. We have equivalent or parallel form. This one now. For the same thing, you have two ways to test it. For example, people that are testing RDT, is that we understand it very well. Test RDT to diagnose malaria. So the RDT there are two types of. We have histidine protein and lactate dehydrogenase. Are two different chemicals. No, they use to detect this antigen. They believe that they detect, but for you to use it, is it reliable? Because they may bring some RDT are using one in Oyo, and it's to protein. They take another one to Benue. It's lactate dehydrogenase. Are they actually, they say the RDT is the number that positive. As this same RDT is histidine protein and lactate dehydrogenase, are they actually testing the same? So if you want to do it, we call it parallel form, equivalent or parallel form, or alternative form, because they are alternative. So if you want to test, you have to administer, take the blood, and use the two RDT for each person, the same person, and see if they are consistent in their result. They mean the same. If this was a positive, if it is possible with this one also, that's what we call parallel form. It's a form of reliability. We now have internal consistency. We talk about all those ones split up, Kuda-Richardson, Kronberg, all those ones are the method, KR20, KR21, they are method they have devised over the year to measure this. But the one that is most popular that is yes now is the Kronberg alpha. So I will explain, we've got to talk about that internal consistency Kronberg alpha. These are the measure of reliability. Scoring agreement, test return, equivalent or parallel, internal consistency. So when they say agreement, you have inter-rater also percentage agreement. Let's talk reliability coefficient. The reliability coefficient is an absolute number that can range from 0 to 1. So it is when you are able to, what you are measuring is score, is number. You can talk about reliability, and this one is actually correlation. That's all. It's correlation, actually correlation. The reliability coefficient is correlation. You know, correlation is from 0 to 1. But here, we don't talk about whether negative or positive now. It's just that value 0 to 1. A value of 1 indicates perfect consistency. A value of 0 indicates a complete lack of consistency. You know, a lot of things with 0 to 1. Probability is 0 to 1. 0 means it's not. 1 means it's perfectly possible. So it's the same thing, it's the same logic. So a value of, okay, scores assigned to the test taker by a complete random process will have a reliability coefficient very close to 0. Scores assigned to test taker by a completely random process will have a reliability coefficient very close to 0. Now, the reliability coefficient is actually a correlation. Now, let's look at type of reliability practically now. Though we have already talked about them, just the flow chart, but to explain some of them, those ones I've talked about. Type of reliability, what is it? How do you establish it? How do you establish the reliability itself? What the reliability coefficient look like? Even though the arrow, that was correlation, but there are some other coefficients that are not actually correlation, but they are still from 0 to 1. Current kappa. So look at test return, a measure of stability. Administer the same test, measure at 2 different times to the same group of patient participants. Correlation coefficient. You correlate the two results. You run the correlation. Then parallel form, a measure equivalent. Administer the two tests for the same test to the same group of participants. Correlate. In this situation, if it is figure, you are scoring, you do correlation. But if it's like the other one, like the one I say is histidine protein, like if it is either there or not there, parasite positive or not, you are not using correlation. So we use this agreement current kappa. But the current kappa also, the issue there is that in current kappa it make more sense when you have more than two options. So unless in this test you say okay, positive, 2 plus, 1 plus, negative. In that case, it is easy to use that current kappa. Inter-rater. So inter-rater means two people and one person. Do it in two people, two different people. They administer the same test to the same person. So the group of person, maybe there are 10 of them, you administer it, another person administer. I want to see your score, two of you. If it is, it may be you also, you first administer it, later I go back and administer it. That's inter-rater. Then we use current kappa. A measure of how consistent each item measure the same underlying construct. Correlate performance on each item with overall performance. Split out, come back out. We'll talk about it because we talk for you to understand that internal consistency, we understand construct, construct. Now, this one is, there's some of these we are not running it because we have run test research. Just this is an example. A quality of one, I didn't share this one with you. Quality of one, first visit, and quality of life versus visit, quality of life second visit for a group of people, about 30 people. So you correlate, just correlation. Person, look at the formula you want to bet, the computer will give it to you. Look at the correlation is 0.615. So sometimes anything that is less than 0.65 or 0.6 is not reliable. So nobody has ever chosen any value less than 0.6 are reliable. You have 0.6, 0.7, 0.65 reliable. So anything less than 0.6, less than 60% correlation is not reliable. So now another example of I think this one is the same thing also. Test retest. Test A, test B, parallel form rather. It's the same thing. Parallel form, the way you do it is the same thing. No, the other one, test reset. You go on two occasions. Be this one, there are two different, you administer each of them, two of them to each person like that. Look at subject 1, 2, 3, up to 10. You administer what are the results. You correlate it. You expect in this correlation now is 0.76. I say that it's a little bit high. The correlation that is the test can say they are reliable, they are doing the same thing. So I don't want to bother you because we have wrong correlation. So we'll have, though I didn't even share the something with you, but I shared this one with you. Kappa, inter-rater. So current kappa index of inter-rater reliability is formula. But let's explain it. M is total observed frequency. OD is sum of observed frequency and the diagonal. ED is sum of expected frequency along the diagonal. He said this statistics is used to assess inter-rater reliability when observing or otherwise coding qualitative categorical data. Kappa is considered to be an improvement over percentage agreement to evaluate this type of reliability. Now, I think I have a data there that will explain it. Look at the table below. Shows the distribution of score of 2,104 two surface made separately by two dentists using a scale of 0 to 3. They rated. So 0 to 3, there are 4 scale now. 0, 1, 2, 3, 4, 3. Calculate the current kappa inter-rater reliability coefficient. So it has been calculated. Dentist 1 is the one along the dentist 2 is along the column. Can you see how, if you look at it, dentist 1, the total has scored 0 is 1,008. Their score 1 is 223, that's score 2, 25, 3, 18. For dentist 2, the total that score 0 is 1,008. That score 1 is 204, score 2, qualified and score.
We can't hear you, sir. Well, I can't hear you.
You cannot hear me?
You went low for a while. Yeah.
Okay. I'm just going through the score that table. So do two dentists, we just calculate it. Then what you use to calculate kappa here is the diagonal. If you look at it, the diagonal is the concordance, where both of them agreement. The people that dentist A says 0 and dentist 2 says 0, they are 1,785. The people that dentist A say 1 and dentist 2 say 2, say 1 also is 154. The people that dentist A say 2 and dentist 2 say 2 also is 25 of them. The people that both of them say 3 is 14. So is the agreement. Those are all those ones that maybe dentist A say 0 and the dentist 1 say 1. Those ones, they just leave those ones. They are off. So it's the agreement now. So you see, because it's the formula, you have to now calculate the expected value of the agreement. What are the expected frequency along the diagonal? You remember the way we calculate the expected frequency. Row total, when we explain chi-square. Row total is the same logic because it's cross tabulation. Row total times column total divided by grand total. So when you do it for those diagonal, that's how we calculate it now. It gives us 1,602.144. The first cell, the first diagonal cell, it gives us 21.3 for the second one, 0.51 for the other one, 0.22. Those are expected value. Expected value mean that the value, what you expect, the frequency you expect, if there's no difference in their rating, what should be in that place? So when we run the kappa, the agreement is 0.737, which is far above 0.7. So we can say that the method is reliable. So let somebody share the kappa so that at least let's run it. Kappa is one of the things I gave you. Nobody? Someone is Samira, Asmao, Mercy.
Yes, sir.
Yes, share kappa now. Kappa. Kappa not ready to share. Huh?
Okay, sir.
Kappa.
Okay, sir. It's loading now. Sir, it's loading now.
It's not shareable.
No, sir, it's opening. The kappa is opening. I had not opened my SPSS previously.
Okay. Thank you, Mercy, for having mercy on us. If you are not here now, many people don't want to share. Well, Mukhtar also share. It's those days that Asma share recently now. Anyway, I think she shares the last 2 times, the last 2 days. The other are not even anyway. We didn't see it again. It was coming, we didn't see it again.
Okay.
You see, the value, the rating have been entered for dentist 1 and 2. So go to analyze. Analyze. Click on analyze.
Yes, sir. This thing is showing on my screen.
It's there now. We can't see your cursor being there. Click on analyze so that.
Yes, there's something. There's something that was blocking my analyze. So I'm here now.
Descriptive statistics. Cross tab is the same. You know, anything I have to do by 2 by 2 table by the contingency table is cross tab. So move dentist 1 to as row, dentist 2 as column. It makes sense. The first one to be row, that one should be column. So go to statistics. Click on the statistics. So you see kappa. Before risk and maximum, lower down, kappa. Can you see now? No, so when you do cost tabulation, it depends on what you are doing. If it's chi-square you are doing, you know where to go. If it is maximum, if it is risk, relative risk, or odd ratio, you know where to go. So continue and okay. So you have to stop sharing and share the results.
Okay.
Yes. So yours, you see, can you see? Kappa is 0.737. Can you see? So you do the cross tabulation for you just the way I show it. So that's all. So all these paparazzi are just for you to understand the logic behind it. Any question concerning it? So you can do your kappa like that, just run with SS. You need to use hand to calculate. So all these things just for us to, you can stop sharing. Message. Thank you.
Okay, sir.
Any question concerning that one? If you look at the calculation, rigorous calculation, eventually it gives us 0.737 also. You use hand to calculate. You say K kappa is diagonal, some of the diagonal minus. You know, some of the expected frequency is ED. Then some of the observed frequencies along the diagonal, OD. Total observed frequency, M is total, that is the grand total observed frequency. So you will see, if you put the formula, it gives you the same thing. So let's talk about Chromback alpha, internal consistency, internal consistency as a form of reliability. So, and the method that is most used, most reliable among all of them is Chromback alpha. Chromback alpha is a measure of internal consistency. That is how closely related a test, a set of items are in a group. It is considered to be a measure of scale reliability. A value of alpha, that's Chromback alpha, does not imply that the measurement is unidirectional. It just measures that they are related, consistent. They are related. Chromback alpha is not a statistical test, it's a coefficient of reliability or consistency. Chromback alpha can be written as a function of the number of test items, the average intercorrelation among them. Just leave that one. Let me just explain it to you, what it actually means. If you have, maybe you have about 20 items measuring particular key. For example, now, quality of life. There are 20 questions, for example, I measure it. And those questions, we usually put them on a scale, maybe 0 to 4, 0 to 5, 1 to 4, 1 to 5. Depends. Even once is anything at least 3, is a scale. But if it is only 2 categories, it's not a scale. Once is 3, 4, 5 or more, and that's the scale. And if it's like that, if you say this thing is measuring quality of life, this question, 20 questions, all the questions should be directed to, they should be saying the same thing. The reason means that if somebody, you administer, somebody score high in question 1, somebody score lower in this same question. If that particular thing, all those questions, they are measuring the same quality of life, the person that score high in question 1 should score high in question 2. And the second person that score lower than you should score lower than that person also. Because if it's usually measuring that quality of life, somebody that is high will want to be consistently in many of them. Somebody that scored low in one of the questions will score low consistently in many of them. So if you just score high in one, anybody can score low in another, moderate in another one. Are they actually measuring the same thing of life? If they are measuring different things, because if they are pointing towards that same quality of life, all those questions should be related. That's what it means. So, intelligent people here, see, how can they call it internal consistency. How do you measure that internal? That is, those instruments to be consistent internally. Why can't we just divide the question into 2 at random? They will now sum, maybe there are 20 now, divide them into 2. At random, you set 10 of the question, you sum the score of the participant, then another 10 of the question, the other 10. You sum the score and now correlate it. Because if all of them, they are pointing to the same thing, the people that score high in this half should score high in this half also. That's the logic behind that split out reliability. Then many people falter in the sense that there are many ways you can split question into half. 20, like for example, 20 questions now. You can decide to question 1 to 5 to 10 will be in 1. Question 11 to 20 will be another one. You can say odd number will be 1, and even number will be another one. You may flip at random, just select some tests. So there are different ways. That shows that if I split the same question in a different way from you, you may not get the same thing. So that's why Kronberg, very intelligent fellow, what he now did, he will pick one of those questions and correlate it with the sum of the rest. He will pick each of them and correlate the score with the sum of the rest question. So at the end of the day, he has done it for all of them and now calculate the average. This formula is in, and that's what it actually means, but you don't need to bother yourself. But that's what they just did. Believing that it has taken all of them into all the items in the question into consideration in calculating the internal confidence. Of course, as we have already said it, it's always on a scale of 1 to 0 to 1 rather. It's the correlation. So here now, a 4-item questionnaire, in each of the items was scored on a scale of 1 to 5. was administered to 60 respondents, calculate the Cronbach alpha coefficient as a measure of internal consistency of the question. Now, so the original way I brought it is somebody's work in a venue, one PhD work that help analyze. Number one, the sample size is one that I did. I just got the first 30. The question is plenty. I just take the first 4. Reason for ease of demonstration. So that somebody can calculate here the Cronbach alpha and now.
Yeah.
Hello. So we calculate the Cronbach alpha and give us 0.839. All those rigorous calculations. You don't need to bother yourself. So let somebody share Cronbach. I think it's there. Cronbach alpha. Cronbach alpha. The data is there. There's something.
Sir, can you see it?
Yeah, we can see it. So let me. We can see. If I can see, other will see it. Thank you. Yeah, those are the items. Good of you. So go to analyze. You go to scale. Down, scale. You have reliability analysis. You have click on it. So click on statistics. Okay, first of all, move all of them. Move all of them. You don't even need to click on statistics. Those ones there, yeah. So they are gone. Look at that alpha. Can you see? Because it's the most common. Click on that arrow. You see it gives other method. Split half, Gottman, parallel, strip. Because I've already said the one that is after all of them are described all this thing over some year that this Cronbach now came with this Cronbach alpha. That's why if you listen, look at it, by default is there. But some other thing, click on that statistic. I don't think there are some other thing which may not even need to achieve. I know that correlation variance. Just leave it. F test. Leave it and click OK. No, wait. Okay. Okay. No, don't worry. Let's go and show us the result. Because I saw something. Okay, click on that statistic. I saw something. Okay, don't worry. Show us the result. So you see Cronbach alpha is 0.839. That's what we calculated. So that's how to. So once you know the logic, you know why you are using it. No? Computer give it to you. You see the way we enter the data. Simple. Some of those, I'll share all those documents in the data set with you. If you have similar thing, you just enter. No, the one example I actually give, actually sample size is small. It can be light. The reason I did that deliberately is for all to, I don't want something that you cannot get because I demonstrate it with hand, calculate it, and use machine to do it. No, if the sample size too many, so it will be cumbersome calculating with hand. In those days, that's what they do. They calculate with hand when there was no computer. by that time, they cannot do much for large sample size anytime. Okay. You can stop sharing. Let's proceed to let's discuss validity. So we have talked about reliability. Some of these other Hartman, all those ones, just the agreement, just leave those ones. It's not commonly being used. This is when I was doing those. Though if you want to know much about them, on the YouTube, all those videos, they are there. They have done a lot of job on them that only maybe for the weekend it's validity and reliability we are doing. On the whole weekend, go to town. All those Hartmans, all those, you see the video. If you want to go, you can watch them. They're very simple. Let's talk about validity. Yeah, validity. We have already said that it's a measure of how well the method or instrument measure what is supposed to measure, how to measure. So there are different approaches to assessing validity. You hear something like, you see the classification I have here, we have translational, criterion, construct. Under the translational, we have phase validity and content validity. I think I have another thing that explain each of them. Yes, they just. Then under criterion, we have cultural validity, predictive validity, and predictive validity. Under the construct validity, we have internal construct validity. Under we have convergence validity, discriminant validity, non-group validity, and we have external construct validity, which is logical validity. So validity may be specific to a particular time, sample, or context. As I have said, it may be specific to a particular instrument, even a particular tool, or a research tool, or the whole study. Internal validity, where the findings are only valid for, that's another context. Apart from this one, I explained transitional criterion construct. Sometimes in another way, you want to look at, okay, where the finding, you want to see this finding of this study. Is it valid for the research setting alone, or is valid to any other, even people outside? For example, now, you do a study in Imo State now. Somebody will quote it in US, work done in Africa. They will not even say in Nigeria, in Africa. If it is South Africa, they are quoting work done in Nigeria. But if it is Nigeria, not say somebody from work done in Imo State. Now, why it is easy for them to refer to work done in Imo State as Nigeria or Africa is because of the external validity. So if the finding is only valid to even those people that they do the work, so it's not even, if it's not valid to people outside that community, that place they took the sample from, that it may not have the internal validity, but it doesn't have the external validity. It's the external validity that actually makes it. By nature, study experimental design has higher internal validity and lower. Observational design usually have higher experimental design, because you know, in experimental design, a lot of restriction, a lot of, you have control for a lot of confounder, a lot of, from the design stage. Now, external validity can be population validity, where generalization to a wider population is justified, or ecological validity, where the generalization to other social contexts is justified. You just say, oh, work done in Southeast Nigeria, and they did it just one local government in Umuahia. But the issue there is the external validity, which is population validity, allowed to say, believing that it's the same context, the same Southeast. But when you are the same thing, we use it for Nigeria. That's more like ecological validity, because we are in the same region, summer, or social context. So let's look at it vividly. Face validity is a measure of how well the item can be seen to have a common relevant type. The item in the questionnaire, the item in your questionnaire, as you are going through, I think usually say you were mentioning quality of life. Those questions, are they questions on quality of life or something else? One that you see you are doing quality of life, you are now asking question more like perception, or more something. Have you heard of knowledge question? Have you heard of this one? Are you aware of this? That is not. So, face validity, look at the item. Do they have common relevance? Is it what they have? Is it relevant to this to the topic? And all of them, are they commonly relevant? And it is carried out by experts. So you now, when you are doing your study, most of the time is your supervisor that carry out the face validity. Because you submit, it goes okay, it's okay. They add more questions, or those questions they are not addressing quality of life, no assessing perception. So in that you had this, and that's okay, it's okay now. What is face validity? The other one that is close to this is content validity. It's a measure of how well the item represents the entire universe of items. So if, yes, the question you have, all those items in the question, yeah, they are relevant. But there are still some other aspects you have not touched. It has excluded some, because when you look at the subject, if maybe we are talking about quality of life now, and some people say they have social aspect, we have psychological aspect, we have environmental aspect, emotional aspect, physical, social, emotional, psychological, environmental, different area like that. That when you talk about quality of life, if maybe you cover some, it's not content validity is very low. So it's still the same expert or expert also. Your professor that okay, you go through and say, okay, all those areas of quality of life have been captured. That's content. So that the question is relevant, that's face validity. That it cover all the different aspects is content. You see, if you look at it, the two now, they are subjective in the sense that it just depends on somebody expert. So what the person now do now depends on how expert is the expert. If you have supervisor, an expert, another person has supervisor, expert. If one is more competent than the other, especially has more knowledge of methodology, or is vast in this area more than the other person, we can see that there will be different way. The validity, the extent to which the thing is valid will be different, subjective. But when you now come to all those other ones, yeah, a little bit objective in the sense that you have to measure something. Criterion validity. The criterion relate to agreement between the measure and another measure, which is accepted as valid referred to as gold standard. Although there is no gold standard for topic like quality of life, therefore, proxy measure can be used instead. So, for example, now let me give an example. When you want to do cervical cancer screening, pap smear, the gold standard is biopsy. If you want to validate pap smear now, the pathologists or the people involved, what they will do is that from they will have gathered a group of people, take biopsy from them, from that place, except for histology. I also take the pap smear. You know, the pap smear just the cell on the surface, they just scrape. So by the time they do the reagent and classify that, oh, it has cancer or has is squamous cell carcinoma or whatever, is positive, not positive. They compare with the gold standard. The gold standard is the biopsy. So you must be, and that is the criterion. That's the criterion. That gold standard is the criterion because it's actually the one that's measuring the criterion. It's measuring the cancer. It's the one that is best that know that if there's cancer. So sometimes also, if it may not be physical thing like a capacity, it may be instrument like all those depression scale. If there's one scale that has been used, that have been known to be yes, and that person now brought another scale. Most of the time, if that scale that is considered to be the gold standard is too lengthy, too cumbersome to administer, so people want to look for simpler one, maybe that is not as lengthy and easy to see if it will measure the same thing as the other one. If it can measure the same thing as the other one, if it is valid, it is valid because the other one is considered to be the gold standard. But you now want to validate this other one criterion. So under the criterion validity, we have what we call concurrent and predictive. A concurrent validity is a measure of how well a test or method estimate a criterion. So you have to select a criterion and correlate the result on the test with score on the criterion on the present. For example, now the passment we are talking is the form of concurrent because it's at the same time we take sample for the gold standard. If we want to measure the validity of the pap smear, we take biopsy, also take the pap smear, and now compare the result. That's concurrent. But if predictive is a measure of how well a test or method predict a criterion, so the predictive now has to do with something futuristic. For example, now, if you want to validate, want to know this exam, WAEC exam, does it actually test the knowledge of this student? Is it valid? Does it test this? Because some people just score high, have A. So people, when you get to university now, I've seen people that have when we talk about exam, it's not only the question, the way they carry out is everything, the whole package. I see people that have A1. When it comes to ordinary, in fact, their CGPA in the 100 level is 1 point something, 0 point something, I'm telling you. And they have A1 in physics, A1 in mathematics. And this person, ordinary elementary mathematics, is free. So if you want to validate now, how do you test if WAEC is true, is truly measuring their distance? You can only use predictive. The criterion is that these students actually know the thing. So we may now use their performance in the university. Some people that cannot survive, someone that have A1, if you in engineering, he cannot survive, have A1 in mathematics, A1 in physics. You expect the person to do well, at least in engineering, if you enter for engineering, enter for courses like medicine or whatever, if he has A1 in physics, chemistry, biology, and at the end of the day, the dropout is he can't even spend, even ordinary chemistry, the chemistry, that is the same chemistry in the 100 level, you cannot pass it. So their success, their score in the 100 level will be the gold standard. But you know that the time they did you collect the data, the WAEC is passed. It will take some time before you enter university. So if we now we are collecting data about their university and their whole level result, and now wait and collect data For the university, I now have to compare. That's predictive. Sometimes you can do in the form of predictive also. You want to say, okay, you may if you maybe didn't collect later data from you just get the university something and now go back. Wait, what is the university something? That's predictive. They are doing the same, it's just the way you collect it. They are part of criterion because it is you believe that you believe that that is that particular knowledge. How do we know that knowledge there? You believe that okay, it is when you start applying university, or sometimes you may want to say, okay, this performance grade in university, you want to have first class, second class. In the industry where they are working, are the people that have better professionally than the other one. Because what you have, the essence of education is for them to influence the society. So it's not just the score, first class, second class. So you may do predictive or predictive validity. Because the reason is that the data for both of them are not at the same available at the same time. But for concurrent, it's the same time you collect the data, you do the comparison. Now, let's talk about construct validity. It's a construct, a measure of how well a test or a method assess some underlying construct or the extent to which the instrument tells the hypothesis or theory that is measuring. So the meaning of construct is latent. Construct is a latent variable. When you say something is latent, it's hidden. You remember your physics and chemistry, latent heat of fission, latent heat of vaporization, latent heat of fission, that is, fusion means melting to melt. Ice block is melting. You know, if you bring a thermometer to the ice block, or even to the, let's talk about, you put thermometer in water, and you are heating it, the temperature is rising, and the temperature is rising, the temperature is rising also with the thermometer. When it starts boiling, the temperature refuses to rise. It stays at 100 degrees Celsius until the water. Then you are supplying it. That heat is not going to increase the temperature. It's going to vaporize. It's hidden. It cannot be measured by temperature. It's hidden. That's what they call it, latent heat. The same thing with fusion. So when you say something is latent, it's hidden. A construct, happiness is a latent, it's a construct. Have you seen happiness before? The only things that you can look for, some things that you think if somebody is happy, you'll be doing. You'll be laughing, you'll be he's happy, he's laughing. He has called some people today and gisted. He speaks to people in the interrelated with people. He move, talk to people that they not say, oh, you're happy. But if somebody is not happy, he has not called anybody today. He needs to pick up. He doesn't smile. He asks him, he says he's tired. You ask a question, so not say, oh. So happiness is a construct. The same thing with quality of life. The same thing with depression. They are all constructs. That nobody has said, oh, this is depression. They measure it and say, no, it's not something like physics and chemistry. It's something that is construct that is hidden. So people just, when they say they diagnose the bipolar depression, they ask question. Anytime you see are tired of that, they ask some question, they feel that they trying to explain. And they now say, oh, he has bipolar depression. So those are constructs, quality of life, happiness, uh, um, depression, they are all constructs. Now, that construct validity, there are two types. They require this convergent and discriminant. The convergent require that the measure construct should be related to similar variable. The other one require that the measure construct not be related to dissimilar variable. It's just a way of dancing around something that you can. For example, now, I did discriminant construct validity. But when I was doing my part 2, trying to look at quality of life of people living with HIV, to validate the instrument to feel that this is actually measuring the quality of life of people living with HIV. So I now came with the idea of somebody that has HIV that has not gone into AIDS. They come to the clinic, you see them, they dance. Some of them even say they thank God they have HIV because people are sponsoring all the activity, they're happy, they even give themselves some of them job. So wow, some people have HIV, they are on admission because they have developed AIDS. Both of them have HIV. So now the people, the quality of life of the people that have HIV, they don't have AIDS, they are moving around to be higher than the person that is on admission with AIDS. So we administer the same instrument to some that come to HIV clinic, some on admission that have AIDS, to measure their quality of life. That's all. We see, what do? We don't do under tests because for each of them, there are 2 group of people, the same number anyway. We now calculate the average quality of life for both of them and calculate and see that there is statistically significant difference between the 2. That is discriminant construct validity. But another way you can do it, you may want to see in this one, you can say, okay, if you are measuring something and you now have another situation. For example, now the same this I can say, okay, I administer the instrument to people that come to HIV clinic in Lut. Also administer to people that come to HIV or in another teaching hospital. You know, the same setting. I want to see I correlated the result. So the thing should, no, you cannot, it's not actually correlate because they are not actually the same people. They are administered to these same people. I try to find out if there's, if you compare, we want to do that test, you know, we expect that there should not be any difference. That is convergence construct validity. Can you see now? So the method you use are the method that are available, but you must understand the context, the logic behind it. So this one talk much about those constructs or whatever. I think we have I think we have a data concurrent validity. Anyway, the same thing concurrent. Okay, this one, another way of doing it, you can have, that's, yes, another way of doing it, yes, you can, the instrument, if you have one instrument, as I already told you before, if there's a standard instrument before that measure the construct, that have you measure the pressure, and now bring your, you can administer the pressure to the same people and correlate. So in this one now, you are looking at concurrent validity for that. No, this one is no. This one is for criterion. Sorry, this one is criterion. So this one for criterion now, you can see I just solved the what do I call it, for the 2 group, for the same group, 2 instruments, 2 standard. So we see that there are correlation between them. Now the correlation is, I look at the 0. This one, the correlation is not, this one is 0.116. So this one now is not, you cannot say it's valid. The correlation is very weak. So this one can say is moderate. Look at another one, it's moderate. So now there's one when you are dealing with criterion that is not, you can say positive or negative, like issue of if you want to validate now. That one we use, that's why we use sensitivity and specificity. So the lecture tomorrow will be on that, because though it's actually part of the better, that one, because we are plotting ROC, receivers operating characteristic curve. So we talk about diagnostic and screening tests where you have positive, negative, positive, negative. So how to do that? It's a form of validity also. It's a form of criterion validity. So I will not say we have data for that also. This, okay, I think I'll talk about construct. I've already told what is the meaning of construct. So all these other ones, they are just internal. I think I've explained all of them. Internal construct validity. Yes. Different way. Like for example, now when I did convergent, discriminant and convergence, I use t-test. I use t-test to, I don't think I have this data, but I use t-test. We have done t-test. You just to compare the two score, and see if there's statistically significant difference. That's what we have. Any question? I think the only two data we run in that of Kappa and what do I call it? Chromback Alpha. Any question?
Okay.
Tomorrow we do research, so we do a form of criterion validity, diagnosis, or screening test. We plot ROC. Thank you, Mr. Dokwe. Any other one?
So, thank you.
Question?
Yeah,
Okay.
thank you very much for the lecture. So what I wanted to ask was about the phase validity, right? So now,
Which
the
one?
phase
What do you call
validity,
it?
phase
Phase,
validity,
okay.
phase, FAC, okay, the phase validity. When you sometimes when you're doing a study and maybe you don't have a validated instrument for it, because I've seen some articles where they will say like the instrument, the tool used was phase validated by the maybe lecturers at the college
By
of
the
blah 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 blah
supervisor.
blah. So now yes, but they would, well, they didn't mention supervisor, maybe just say lecturers at their college or something, that institution. So now I'm wondering, that means it's something that they put the questions together themselves. I mean, they form the questionnaire themselves, right? And then phase validated it with their supervisor.
Yes.
Does that, how reliable, or what kind of external validation does that have? Yes, how valid that is. If you now form your own questions by yourself and then phase validate it with your supervisor, that's one. Two, does a validated tool that you already adjusted, like now, let's say you're using a tool that you know already, like the WHO quality of life breath or Zari burden of scale and something, but it doesn't exactly capture everything you want. So you find out that you need to make one or two adjustments in that questionnaire to be able to capture what you want for your own study. Do you now phase validate it? It's already a validated instrument used worldwide. Do you now phase validate it, or you just make your own adjustments and use it like that, or you give it to your supervisor and it's good enough? I'm trying to understand, when you adjust the questionnaire to suit what you want, a validated instrument to suit what you want, what you're studying in your own environment, do you just continue, or does it lose its validity, or what do you do to actually make it still valid for your work? I don't know if you got the two questions.
I got it. Yeah. That first one, when you are talking, it's not everything you see. If you look at it, you know, different type of those validity may surface for different scenario. For example, now, knowledge questionnaire, you cannot do construct valid, because though you may say knowledge, you cannot grab it, but it's not something that is measuring a criterion per se. When you say knowledge of tuberculosis, even you that is expert, you have different level of knowledge. That's why you have.
I can't hear you.
When I say knowledge of something, even you that you are an expert in that, for example, knowledge of tuberculosis. So different people have knowledge of tuberculosis, different level of knowledge. So that's why we have people that are higher in hierarchy in a particular field. Though for the fact that somebody is a professor, that may not know that may not mean that he knows a particular thing more than you. But the issue that the knowledge vary. So if you want to know the knowledge of something, that instrument, you cannot say you are validating it with construct criteria. No, you cannot do that. So if I thought that, okay, yes, they want to see that the questionnaire cover aspect of tuberculosis, it's face and content validity you do. Because the knowledge is not, it's different from perception. You understand me now? The knowledge is very of perception. Somehow, even the perception also is close to that. But when we look at quality of life, that one is an underlying construct. So it's not all the situation you can do a particular validity. So that's why the simplest one, face and content, are the one you do for. But when it's a very important thing like something like quality of life, depression, because it's so important that some people over the year they have already validated this. It cannot just be there must be a standard way of measuring it. That's why they are validated and do the reliability of that too. Now, in a situation, for example, quality of life now, they're validated by WHO in many languages. You want to use it. Yeah, you can go ahead and use it. But you can, when I use the same WHO for my part 1 and part 2, National and West Africa, I had to validate them. No, I didn't validate for the national. They are validated for West Africa. And the reason I did that was to make it more robust, because the quality of life is designed for people to use generally in the population. So my national.
What do you mean by you validated it? Did you add questions to it?
Wait, listen. I'm coming there. I didn't ask question. I had a question. So that quality of life breath. This breath is for, they have validated for different group, different languages, and they feel that it's good, and it's there in the literature. Now, for my national, because I did it in the community, so to look to correlate, to look at relationship between quality of life and anthropometric. So this one I didn't validate it. But when I use the same instrument for HIV, that instrument is not for HIV, because some of those there are some instruments that quality of life that have been validated for HIV, for TB, for different diseases. So this one is still the same breath I want to use for HIV. So I now validated myself, and now that's why I did the construct validity. I didn't change the instrument. I just validated and answered that it's valid for even the people living with HIV. So that is what we call adoption. I adopted it. But if you adapt, you try to change something, that's adaptation. You have to revalidate it. Because if you change something there, or you have something to, it's not the same thing. It has changed. So you cannot say that because they are validated. If it's not that you have added something or you remove something, you modify. That is adaptation. You adapted it, not adopt. Adopt, you just use it like that. So you may not need to validate it for adopt. For the adapt, you need to validate it again.
With your supervisor?
Yeah, you can. Let me tell you, if it's something that they are validated, which method? Most of the ones they are validated, they have either use other criteria or construct validity. You should do the validity in a scientific way like that. It's not just with your supervisor. So there are all those sort of things, knowledge, perception, you can say you do face validity. If you want to do depression now, you cannot say depression can you do face validity. I don't know if you understand me now. Quality of life, you cannot do face validity. There are some of those examples I've given, that's what you go to do. You have to collect, and you have to collect initial data during your, maybe you call it pre-test. You will not call it, what do I call it? What's the name of this thing that you usually do before you go?
We see.
No. This it's different from what's the name? If you like a mini study you do before, pilot. You will not call it pilot study. If you say you pilot study, it means that you analyze everything. You collect small sample and you now analyze to get Even write report, finish the study. But it's just a pretest. Pretest, you take the instrument, you pretest the instrument, you take the instrument, just administer to a few people, and you can validate. It's good to validate before you go to the field. Some people, you know what they do? They've collected the something is from their, even the data set they have collected, they have validated. That is wrong. You have already collected now. So you cannot, of course, you have to tell us that it's valid. Because if you have done initially, just like more like pretest, you just collect from few people, you validate, you now discover it's not valid. You are now at liberty to look for other instruments to use rather than that one. But when people are collected, that's it. During the analysis, they say they did validate. No, they are not. It's a lie.
Thank you, sir.
Welcome. Any other question? If there's no question, good night.